Hey, hi, good evening, everyone. Good evening, friends. Welcome back to our session. So, today it's day 9. We'll continue with new topics. Okay, we'll continue the same ongoing topic, that is constraints. Okay, so before that, we'll quickly revise what we have covered in the previous session. Okay, I hope you're enjoying the sessions because we are, getting good amount of knowledge with respect to the concepts of SQL structured query language. And in case if you have missed any of the previous session, I would sincerely recommend to go through the session before you join this class, the ongoing sessions. Right. So we started with the concept of SQL constraints. Right. So what are constraints in SQL? In SQL, constraints are nothing but some conditions. They are some rules on the table. Okay, on the tables that we have in the databases. What is the use of these constraints is they help us to maintain data integrity. Okay, and they also help us to store the data which is accurate, consistent. Right. So what are the different types of constraints that we have learned in the previous session, friends? What are the different types of constraints we have learned? Use text, chat box. I want everyone to answer. So we started with primary key. Okay, a primary key is a combination of unique and not null constraints. Okay, so the values under the column, this primary key column, they should be unique and they should not be null. Okay, so it can be for only one column or for a set of columns. How many primary keys are allowed for a table? It's only one. A table can have only one primary key, right? Yes. Then we understood by taking a example. We created a table, then inserted the data, and we understood how primary key is actually helping us to maintain the data, accuracy, how accurate the data is, right? Yes. And even if you see the data is getting consistent, record to record, you see the consistency. We cannot have null values. Any such kind of examples that would you like to do for primary key? The best examples will be like any of the IDs. Okay, employee ID, student ID, customer ID, product ID, all of these will be primary keys because they cannot be null and they should be unique. None of the employees can have two employees can have same ID. No two students can have same ID, the same. Okay, right. Then we also understood what is composite primary key. A composite primary key is nothing but, you know you are defining this primary key for two or more than two columns. Then it becomes a composite primary key. Okay, so the combination of those two or more than two columns should be unique, and none of these columns can be null. They cannot have null values. They cannot accept null values. Got it? Yes. So we understood the key rules. Okay, so how composite primary can be defined, the syntax. Okay, and then we insert the data. We saw how it is, you know, helping us to maintain the data accuracy. Third key, third constraint we understood is foreign key. A foreign key helps us to establish relationship between the tables. Okay, so between two tables, if you would like to have the established, if you want to create any kind of relationship, okay, so we can come up with a foreign key. The best example is we have a parent table, we have a child table, and if you would like to have a relation between these two tables, okay, we are supposed to come up with a foreign key in the child table, and this foreign key of the child table will reference to the primary key of the parent table. Okay, so that we can create relationships. Why? In the previous probably on a day one we have understood what is RDBMS, right? So when I was talking about RDBMS, relational database management systems, okay, so we understood that these databases can have relationships. Okay, we can create some relationships, we can establish these relationships only in relational database management systems. So if you take MySQL, the ongoing system, RDBMS system that I'm using, I can create relationships. How? This is the process. Using foreign key, I'm able to create a relationship, a relation between tables. Here is the syntax. Okay, a table can have multiple foreign keys. Okay, so it's not like primary key, friends. You can have multiple foreign keys. Okay, so a table can have multiple foreign keys, and this will ensure that you can come up with the multiple relationships. Okay, a table can be connected with the other table or this table or that table, whatever it might be. Okay, then uh, next to foreign key, we understood unique key as well. Okay, so under unique key, or when we generally use unique key, what does this unique key means? Unique key ensures that all the values under this particular column will be unique. Okay, but does it allow null values? Yes, it allow null values. Okay, so it's not like primary key, it is just part of primary key. Primary key means combination of unique and not null constraints, but unique key allows null values. How many unique keys can a table have? A table can have multiple unique keys. Okay, so the syntax is same. At the end of each and every column after the data type, you pass the constraint. Okay, syntaxes, yes, memorize the syntaxes, because in the interviews, as part of interviews, you can expect the questions with respect to syntaxes only. Okay, you'll be questioned on syntaxes. So memorize the syntaxes. Then, as part of unique key, I can also come up with a composite unique key. Two or more columns, combination of these two or more columns should be unique. That represents a composite unique key. Okay, all these topics were done. So we also understood how we create a composite unique key, and the data got inserted, and we understood where it is actually throwing us error. Done. Now today we are going to learn few more constraints that we have in SQL. Okay, in SQL we have few more constraints. Then additionally, after completing the concept of constraints, because these are very simple, the rest few constraints that we are going to discuss today, they are very simple. So after understanding these constraints, we'll go back to the operators. You remember, under operators we did not discuss the concept of union and union all operators. So today we are going to understand those two topics as well. Right. So I'll start with not null constraint. So I need not specifically invest good amount of time on not null. Not null means this particular constraint ensures that a column cannot store null values. Okay. So if we are defining not null constraint for any of the column, that particular column cannot have null values. It cannot store null values. So what are the key properties or the key points that we have under not null? It prevents null values, and for which kind of fields we generally use not null? For IDs, names, mails. Okay, wherever the missing values are not accepted, for those fields are nothing but columns. For those columns, we generally use not null constraint. And within a table, how many not null constraints for how many columns we can have this not null constraint is, you know, if you would like to have for all the columns, you can add or you can define this not null constraint for all the columns of the table. Okay, so for all the columns, it can be applied, but depending on the requirement. Clear? So I'll take an example, and probably I'll go with this example. Focus. So what am I doing? I'm creating a table named students. Okay. So you see here, for student ID, I have primary key. Is it a valid constraint for ID? Yes, because student ID cannot be null and it cannot repeat. So it should be unique. So out of all the columns, primary key should be defined for student ID. That's good. Then student first name of the student. So can it be null? Impossible. If a student does not, have any name, how are we going to store or how are we going to give some kind of admission? Okay, so for sure they have to reveal their name because name is an identity for a person. So you know, uh, if you mention not null, the student cannot escape before you know giving the details. So for sure we ask them to provide this first name. The value for this particular column has to be provided. If they did not provide, their values, I mean, their record will not be accepted. Then last name, yes, probably in some cases, some people don't want to disclose. So even though if you want to keep not null for last name, yes, you can add not null constraint for last name as well. Then email, every student will have email, so specify not null. Then for age, I have a condition or something. There is something called as check. Ignore this. This is one more constraint that we are going to discuss in the coming few minutes. And finally, enrollment date. So on which date this student has enrolled has to be updated in the table. Okay. So I'm creating this table. Table got created. Let me go and check. So it got created students. Let me see the data. There is no data. So let us insert some records. Done. What am I doing? I'm inserting the records into the table. So let me see, will this be accepted? Yes, it is accepted. Now I'll try to go through the data. Clear? Yes. Now I'll insert one more record, but this time, what am I doing? You see, I'm trying to insert the values for some of the columns. Do I have value for first name? No, because the value Smith is for last name. It's not for first name. So that means I'm not inserting any value for first name. Will this record be inserted or will it throw any error? Come on, friends. Will it be inserted? It will throw an error. The reason is we had not null constraint. See, field first name does not have a default value. There is no default value. Okay, so for sure you have to pass a value for first name column because we have not null constraint defined for first name, right? So that is the reason it is not allowing us to insert the record. Fine. Let me go to the next example. What am I doing? I am inserting one more record, a student detail, ID, first name, last name, age, but this time I am missing out email. Will it be accepted? Again, the answer is no. It will not be accepted. The reason is, you know, there is no default value. We had a not null constraint, and this not null constraint ensures all the values are not null. It does not allow null values. Got it? Yes. So I hope it's we had some good understanding with respect to not null constraint. Let us go to the next constraint. It is default. It is default. What is this default constraint? What is the purpose of using a default constraint is a default constraint assigns a default value to the column if no value is provided during insert operation. So whenever you are trying to insert the records, right? Okay, when you try to insert and if you don't pass any one of the value for the column, okay, by default if you specify a value for that column, that value will be inserted, and that is because of default constraint. Okay, so for suppose if I keep it as not null, then default. Okay, so for one column you can have again many constraints defined. Okay, so don't assume for one column we can have only one constraint. For first name I can have one or more than one constraints defined. I'll go and explain now with other examples. Probably you may understand. So you see here the key points is it assigns a default value automatically when no value is specified. It helps us to avoid null values. We cannot have null values if you define a default value. If we define a default constraint, we cannot have a null value, and it generally works with numeric. I mean the columns of numeric columns, date related columns, or string, whatever it might be. Okay, so it can be combined with not null to ensure every row has a value. In order to have a value for every row, it is generally combined with not null constraint. See here we have an example. Here we have an example. You see, my bad. It's not current date. Or let me take timestamp. Why it's not allowing? Go back. Not today. Or let me take one date. That would be best. 2025, probably 02, 03, 08. Okay, I have changed the date anyways. It's throwing some kind of error for me. I'll explain. See, friends, what am I doing? I'm creating a table. Okay, and the name of the table is employees 2, where we have ID, name, department, salary, and the hiring date of the employees. Okay, so the constraints, if you observe the constraints, employee ID has primary key, then name has not null. Okay, so name cannot be null, so that is the reason we went with not null. Then department, under department, if the employee explicitly defines when we are going to pass any value for the department, that particular value will be inserted under this column. If not, the default department value will be general. In the same way, salary, if I am passing any value, if I am trying to insert a record, if I specify the salary, that amount will be considered and it will be inserted. If not, this 50,000, sorry, it's 5,000. Okay, 50,000. So 50,000 will be, you know, inserted, the default. In the same way, hire date. Okay, since it is a date related column, I took the date as the data type. Okay, so date format, the default, this particular date will be considered. Anyways, let me create the table first. It's done. I have created the table. Now let me start inserting some records. What am I doing? I'm inserting the record. Okay, but what are the values that I'm passing? I'm just passing only employee ID and name. But what about the rest of the three columns? Am I passing any values? Am I inserting any values? You see, there are no values. Will it execute or not? Just go for a wild guess. Will it execute or not? Come on, friends. No or yes? The answer is the answer is yes. Why? See, ID, the value is 1. For name, this John Doe is going to take. Okay, so if you take rest of the columns, department, salary, hire date, am I passing any value? No, but still, why did it execute is, even though if I don't pass value, because of default constraint for these three columns, the default values will be inserted. Okay, so don't get confused. Look after the constraints. Let me go and check. I'll go and have a look at the data. You see, the department is general, salary is 50,000, hire date is the date that we have provided. I hope it's making sense. So in this way, default constraint helps us to, you know, insert the data. It ensures that none of the values for whatever the column you are specifying the default constraint, that particular column cannot have null values. Okay, a default value will be inserted every time. Now if you see, I'm inserting one more employee details, but this time I'm passing all the all the values for all the columns. Will this execute? Yes, this will execute. The reason is, either if I pass or if I don't pass, I'm not passing the values here. But why did it execute is because of default values. Even if you pass, these values will be inserted. Okay, so I'll execute. Sorry, is it a duplicate entry? Where do we have duplicate entry? Duplicate entry 1. Just give me a minute. Yep, sorry. You see, the new record has been inserted. Simple. See, if you pass that value for the default constraint column, that value will be considered. If you don't pass the value, the general, I mean, the default value will be inserted. That is what we are trying to understand. Nothing else apart from it. Clear? Okay. What if I want to, change that value? Okay. If I want to change the default value, how? Go to alter DDL commands. You see here, using alter table, I mean alter command, I'm changing the default value for the column department. So by default it is general, right? If I want to change this general to some other value, the default value has to be changed. Then go and use alter command. The syntax, same syntax, alter table name. Then specify what you are going to do. Alter column department, set default sales. You are changing the default value to sales for department column. Done. Done. How do you know that that this particular change has been done? How do you know that the default value has been changed? Yesterday we have discussed it. Come on, friends. How can I know that the default value has changed? Describe, then the table name. You see, using describe. See, whenever you try to use describe, probably yes. When you use describe table name, it gives you the complete information regarding the table. The column names followed by the types. Types represent the data type. Then whether those columns will accept null values or not. Then next to it we have keys. What are the keys were defined for each and every column? And finally the default value. Is it got the default value for the department has been changed? Yes. From general to sales it has been changed. Okay, clear? Perfect. If we have one more no uh, query with respect to default, what if you would like to remove a default value? That particular constraint has been should be removed. So what is the process? Simple. I'll use alter command. So this particular alter command, using alter command, I'm going to drop that constraint. Not only default, friends, it might be any constraint. If you want to drop or if you want to change, you know it has to be done only using alter command. So that is the reason, on day one itself I have told, probably on day two, these five languages DDL, DML, DQL, DCL and TCL are very 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 important. Okay, so if you understand them, these five commands or the five languages properly, your fundamentals are, you'll be very good at the fundamentals. You can answer any kind of question being a fresher. Because yes, Probably a freshers can be expected only a general questions, but experienced, it will change. The level of questioning will be changed. Right. So I'm going to drop the you know constraint default for department column. So I'll execute. Sorry, it's done. I'll go back. I'll run it one more time. Excuse me. You see, there is no more default constraint for department column. Done. It's removed. Clear? Yes. So let's go and understand the next constraint. It's check. So far we understood default and not null. Okay. So this check constraint is the third constraint of the day. Right. So what is check constraint? What is the purpose of check constraint is a check constraint ensures, okay, that a column values only if the column, for whatever the column you specify this check constraint, and when you try to insert the or update the values for this column, a specific condition has to be met. Okay, so if this condition is not met, the values will not be updated or inserted. Okay, simple. In the previous case, what we have done, when I'm trying to insert the data for students, I was asking the age of the student. Can a student have less than 0 years, or you know, can a student have less than 0 years or age as negative? No, impossible. So when a student age is given in negative, it does not accept. I'll take an example. But before that, we'll understand the key features. This check constraints, it ensures valid data entry. Whatever we are trying to insert or update, it you know validates whether that particular record is a genuine entry or not. How? Because it is cross-checking the condition, right? If the condition is met, yes, obviously. If not, it may not be a genuine entry. Then it can be applied to, yes, one column or multiple columns, and generally works with same numeric text date related values. Okay, so if the condition is not met, it returns, or it returns it throws an error. I'll take an example. See, what is the condition here? I'm trying to create an employee table. Okay, but if you see here, I have defined check constraint for salary. Can salary be negative? Impossible. Impossible. Can age be negative? Impossible. Right? Yes. But the conditions that I'm specifying here are different for different columns. What is my constraint for age? So this is the condition. Check, using check constraint, I'm specifying the condition. Only if the student age is greater than or equals to 18, then it, it will be a valid entry or a genuine entry. If the student age is less than 18, okay, then it's not a valid entry for me. Okay, probably I want to conduct an exam based on their age. Okay, so you know this is something I have to go and cross check. And salary cannot be negative, so it has to be greater than 0. I'm keeping a condition. The condition says salary should be greater than 0. So let us create this table. Table got created. Now I'll try to insert the records one by one. What are we doing? We are inserting records into the table employees 3. Okay, and I'm passing employee ID, name, age, salary, department. Okay, before inserting, it goes and checks the conditions. Age greater than 18 or equal to 18. Yes or no? Yes. 25 is greater than 18. True. Then salary greater than 0 or not? Yes. So since the conditions are met, you know, it will insert this particular employee details. So for better understanding, I'll go and have a look at the table. You see, the employee details are inserted into the table. Right. Then I'll insert one more. See, whatever we are trying to do are a basic part. Okay, so as we are learning structured query language, we are taking a basic examples and we are learning it. But in real time, you'll apply the same concept. Probably the data will change. That's it. Okay, you may apply check constraint on some other column depending upon your project. The same primary key, not null, but the concept remains constant, friends. Okay, don't assume that this particular sessions are not useful. Okay, so think of. Anyways, I'll get back. Now if you see, is the age constraint met? Age should be greater than or equals to 18. Is it greater than or equals to 18? 16 is greater than or equals to 18? No, 16 is less than 18. So since the condition is not met, when you try to insert this record, it has to throw error. You know, why? Unknown column name in field list. Okay, probably you have to get an error with respect to check constraint, but it's not recognizing name. Might be because of this. Okay, I'll cross check. You should get an error with respect to check constraint. That will be the actual error. Excuse me. But I hope you are clear on the concept of check constraint. It has to throw an error. Yes. And finally, it's the candidate key. Okay, so in total we understood 7 constraints today, and so far so far we have understood 7 constraints. The eighth constraint is candidate key. What is a candidate key? A candidate key is a set, or it's a set of one or more columns that uniquely identifies each row in a table. Okay, if you have a table, in the table if you have the records, using one or more columns, you know of these values, column values, if you are able to uniquely identify each row, that becomes candidate keys. Before we understand candidate key, there are a few more points to be discussed. you know a table can have multiple candidate keys, but one of these candidate keys chosen as primary key. One of the candidate key is chosen as primary key. So that means primary key is nothing but a candidate key only, friends. Okay, I have a table in which there are 5 columns. Out of 5 columns, 3 columns are candidate keys. Okay, so these 3 columns, out of these 3 columns, one column will be chosen as primary key. Okay, so what exactly is candidate key, we'll understand. If you understand the key points, you'll understand. See, uniquely identifies each record. So that means all the values under these candidate keys should be unique. Then nothing but no duplicate values are allowed. So you cannot have duplicates. Cannot have null values. Null values are also not accepted. A table can have multiple candidate keys. So combination of unique and not null will make us, well, it will return as a candidate key. So here is an example. See, here is an example. I'm creating a table. It is students. Probably I have to make it one because I knew how I have students table here. So it's students one, ID, roll number. But for roll number, how many constants am I using? Unique and not null. Two constants. Email, unique, not null. Okay. But primary key was assigned to student ID. So what do you understand? How many candidate keys do we have in the students one table? We have in total three candidate keys. How? Student ID is a primary key. Primary key is nothing but a candidate key. How come? A candidate key is representing, you know, either one or more columns together uniquely identifies the records of a table. Okay, so if you take these three values, these three columns, will these three together represent each row of this table, students one, uniquely or not? Yes, student ID, roll number, email. If I get these three values of the students, I can uniquely say about each and every student. I can identify each and every student. But out of these three candidate keys, only one key has to be selected as primary key. Only one key has to be selected as primary key. So I'm selecting primary key for my, I'm defining primary key for my student ID. So for rest of the uh, you know candidate keys, roll number and email, we just go with unique and not null constraints. Clear? So I'm creating this table, created, okay. Then I'll start inserting the data. See, I'm inserting the data. Will this execute? Yes, it will execute. The reason is, you know, we are not duplicating any of the values and we are not passing any null values. So it will execute. Sorry. I did not change the table name. Probably that is the reason it is affecting. Anyways, executed. Yes. So let me go and check. Here, so we have two records inserted into the table. Right. Then I'm trying to insert a record, but this time you see, will this particular record will be inserted or not? No, it will not be inserted. The reason is we have this roll number already existing in the table. Okay, in the table we already have it. So that is the reason it will not be executed. Instead of executing, it will throw an error. Duplicate entry S101 for key students 1 roll number. For roll number, this is a duplicate entry. It does not allow to have duplicate entries. The same concept, friends, but this is named as candidate keys. This time, so instead of passing a value, I'm passing null values. Will it accept? No. No. Again, you have to get an error. So if I execute again, it cannot be null. So we understood that, you know in this particular table we have three candidate keys. Out of three candidate keys, only one candidate key will be allowed to choose as primary key. Okay, so in our case we have defined primary key to student ID. Clear? So anyhow, we have completed the concept of constraints. Okay, but I would like to add one more important point before I wind up this particular topic. How many of you are aware of alternate keys? Alternate keys, like how we have primary key, foreign key, candidate key. In the same way, we also have alternate key. Are you aware of alternate key as well? Anyone? If you are aware, just keep it as yes. If not, no. I would like to explain alternate key. Anyhow, with the same example, I would like to do it. Okay, my friend says yes. Can you define what is an alternate key? What is okay? So in this table, what are the alternate keys we have? Which column is alternate key? Okay, I'll explain. See, first of all, in order to understand alternate keys, you should understand what are the candidate keys that the table has. We are aware that this table students one have three candidate keys: ID, roll number, email. Out of three candidate keys, one of the candidate key will be defined as primary key. So student ID has been defined as primary key. Again, friends, keep in mind you can define primary key. You know here itself, after the data type, you can keep it as primary key. If not, you can also go to the next line and keep it as primary key. Within the primary key, you are supposed to pass the column. So both the ways are accepted. Okay. Now, student ID is defined as primary key. What are the rest of the candidate keys we have? Roll number and email. So these two will be alternate keys. So primary key is a candidate key. In the same way, alternate keys are also candidate keys, but which is not primary key. That becomes alternate keys. In this particular example, we have roll number and email. I hope it's making sense. Even though if you understand or if you don't understand, that's okay. Don't mind. As an additional information, I would like to convey it. So I'm done. Now let us understand the topic of union and union all. So we'll go back to operators. When we were discussing operators, friends, you know, we did not touch the operators under set. That is union and union all. So today it hardly takes a few minutes. We'll understand this concept and then we'll wrap the session. Right. So union operator. What does union operator does? If you go back to sets and relation concept that we have learned as part of mathematics in our probably seventh, eighth, or ninth standard. Okay, so we have uh, this sets and relations, Venn diagrams, union, intersection, join, disjoint, all these terminologies, right? So let us go back to that stage. What do you mean by union? Union means the entire whole data. Am I right? Yes. When you take two uh, Venn diagrams, I mean, if you take two sets and A union B represents all the records or all the data from both the sets. In the same way, union operator means, you know, it combines the results of two or more select queries. Okay, if you would like to combine result of two or more select queries, go and use union. And this is one more important point. When you perform union operator, it removes the duplicate records. Okay, for example, there is table 1 and there is table 2. And when you apply union operator, if there are any duplicates in the final data set, those duplicate rows, those duplicate records will be removed as part of the output. So here are the key features of union operator. So it is used to combine multiple, queries to a single set. Then it removes the duplicate records. The third one is, whenever you are trying to perform union operator, make sure the number of columns and the order of columns must match in both the queries. Okay, if you are working on two queries, for example, there is one table of five columns and there is one more table of five columns. Ensure that both these tables should have same number of columns and the order of columns should also be same. Okay, even if the order mismatches, it does not allow us to get the output. It will throw error. And this is something important. The data types, even the data types also play a crucial role. They should be compatible, friends. If they're not compatible, you know, you'll not get the output. And the syntax is very simple for union. See, select. So this is one query, one select query. Select star from table 1, then followed by union keyword, then select star from second table. So very simple. Performing union is very simple. For that, I'll take an example and probably we'll understand step by step. So focus. What am I doing? I'm creating a table and the table name is customers underscore 2023. Okay, so assume I'm running some business. Okay, and on daily basis the customers walk in, right? So or whatever it might be, I have the data for my customers in a separate table. For each and every year I'm recording the customers details. Okay, so for the 2023 year, we have a table and the table name is customers underscore 2023, where we have customer id, the name of the customer and the city they belong to. For this, okay, I'm going to create a table. Sorry. So the table got created in the same way for year 2024. Created. Then I'm trying to insert some records first into the 2023 table, followed by 2024. Okay, so you see here in both the tables we have 4 and 4 records. But if you observe carefully, you see customer 3, ID 3 and customer ID 4, are they repeated in both the tables? Yes. Might be both of them are part of the tables. The reason is these two customers, they have bought the products in both the years. That is the reason they are part of both the tables. Yes, this particular person, okay, and 3 and 4 customers with IDs, they have purchased the products in both the years. So that is the reason we have in both the tables. But I'll try to perform union. I'm performing union operator on these two tables. So the syntax is very simple. Star, select star from table 1 followed by union operator, union keyword, then select star from table 2. Simple. Star represents all columns. So you are supposed to mention what columns you would like to have in the output. Either you would like to have all columns or only a specific columns. You are supposed to mention. Since the number of columns and the order of columns is same, I can perform union operator, and this union operator ensures that the duplicates will be removed. The duplicates will be removed. I'll not have the duplicates in the final data set. See, do I have 3 and 4 repeated? No. 3 and 4 of table 2, that is customers 2024, will be removed. I hope it's making sense. This is how we use union operator. Next to union operator, we also have union all operator. We also have union all. So what makes the difference between union and union all? Again, the purpose of union all operator is also same. If you would like to combine multiple select queries without removing duplicates, go and use union all. If you would like to remove the duplicates and combine them, it is with respect to union operator. So that is the only difference between union and union all. There are few more differences, but the primary difference with is union operator will remove the duplicates and it will give the output, whereas union all operator will not remove the duplicates. Even the syntax is also same. What is the difference? The difference will be only changing the keyword. Instead of union, you are supposed to use union all. That is the only difference. Syntax. Let me execute. This time I'll get all the 8 rows without removing duplicates. The duplicates will be as is. It will not be treated. Union on operator will not treat duplicates. The duplicates will be written as it is. Like how we are able to see the output in the same way, when you try to do it on your data with respect to your project, yes, the duplicates will be kept as it is. So before I stop the class, I'll just ask a question. Hope you understood the difference between union and union all. I assume that everyone, watching this particular session understood union and union all operator. Out of these two operators, which operator is generally fast and which operator is very slow? I mean, which operator is fast and which operator is slow? And if you are, you know, answering this question, you should also justify why it is fast and why it is slow. Come on, friends. Which operator is fast and why it is fast? No answers? Or should I reveal? Union is fast, but it will. Uh, union all is fast or union is fast? Which one is fast? Good, good friend. Union all is fast. See, out of union all operator is fast. The reason is it does not it does not work on duplicates, right? Simple. The logic is simple. Union all will be faster as It does not work on the duplicates, whereas union is slow compared to union all. The reason is it should work on the duplicates. Okay, probably you are unable to understand this particular point, which is fast, which is slow, because the data is very small. When you do it on at least thousands of records, you'll understand which operator is fast and which operator is slow. But the reason is this particular thing, you know union operator is slow because it has to work on the duplicates as well. Clear? Any questions? So we are done for the day. It's time for our questions. Yep. So what you'll do is, try using union and union all operators on at least, you know, thousands of records. You'll understand why union is slow and union all is fast. Do it as a task, right? So friends, if you feel that, yes, if you feel these sessions are great and if you are gathering good amount of knowledge, hit on the like button. Ask your friends to join these sessions. Ask them to learn SQL. Not only SQL, we have playlist on Python, then Power BI as well. So soon we are going to launch new programs with respect to machine learning, deep learning, and generative AI. So ask all your friends to register for this particular program, because you know that this particular topics are trending, right? So the chance of getting job with respect to the new technologies will be more. Excuse me. Right? So just convey this message, because as we are doing all the programs on YouTube for free, it's better if you use them in the right way. We'll be in a right position, right? So that's all for the day. The feedback link has been provided. Thank you so much, friends, because the you know feedback that we are getting is really great. So that is actually making us to do new programs. In future as well, we are ready to do all the programs one by one, but it takes time, right? So even when you give some good amount of push from your side, we are ready to conduct similar kind of programs on the new technologies. Okay, everything will be communicated, but some kind of push has to be there from your side as well, right? So that's all for the day. We'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.